Okay, let's continue with page 212. Okay, so here these few pages actually are quite simple and cover in year 10. So I will try to point out some key ideas, and I would expect you to read it by yourself. Okay, so the first thing is EMF. EMF is basically the idea of how much voltage provided by the battery, and we'll learn something. Well, actually, this is not battery. This whole thing is battery, and this is called something called internal resistor, which we'll be talking about in 5.3. Okay, so I don't think you need to care about these for now. We'll talk about that in detail. All right, this is a new thing. Okay, but I'm talking about in general. For EMF is simply the voltage provided by the whole battery. Okay, so here's a list of the symbol of the circuit component. So all these are expected to know, so make sure you know all of them simply. Okay, next page we have actually, if you could finish the previous video, then you should know about this. For the resistor in series, we would just have to add them up together. Okay, maybe I'll zoom in a little bit. Add them up together. The way that we could actually derive is by doing this, and I think if you were in my class in year 10, you should surely derive this before already using the Ohm's law. Alright, and this circuit diagram. And of course we have to talk about resistor in parallel, and when they are parallel, this is the diagram. And what happened is, alright, let's go back a little bit. Just now when we talk about for series, what they do is they will have the same currents. Maybe you may want to write down. So the current is the same, however V will be different. And V, if you remember, is depending on how the ratio of these three R would be. Okay, so for example, for R3, voltage for R3 will be V. V is across the whole thing, times the fraction of R1 plus R2 plus R3, and you take R3, that portion. Okay, so if this is 1, 2, 3, then this basically is 6 over 3. So that means take half of the voltage, half of the total voltage. And if you try to find the equivalent resistance or total resistance, is using this equation. As for the parallel, it will be basically the opposite case. What happened is we have V to be the same because again they are parallel. However, for I, it should be different, or usually it's different unless they are the same resistance. However, when you try to add them up together, for example here I1, I2 and I3, it would be equal to the sum of the currents that are going in. So that's why there is an equation here for parallel connection. And here is a new name that we would like to introduce to you in IB. This law, I just realized that I've been pronouncing it this wrong. I have been saying this as Kirchhoff's law, and I somehow find out it's actually a German scientist. So from the more original way of saying it, it should be more like this.
Kirchhoff.
It should be Kirchhoff's law, or Kirchhoff's current law, or in English,
Kirchhoff.
Or Kirchhoff current law. Alright, but actually it doesn't really matter in physics how you pronounce it, as long as you know what we are talking about. So the law is actually the idea that which you have learned in year 10 already, which is saying that the currents going in equal to current going out. Alright, if you don't understand what that means, it's basically say there's a current going in and then you try to split into three. It's actually just like this one, and then I1, I2, I3. The symbol, I hope you all knows about it. Not sure if your maps cover this. This is summation sign, which means you add these things together. Alright, same as when people talk about Newton's second law, F equals ma. The more proper way to write it is actually like this: summation F equals to MA, or summation small f, or Fi, and I equal to 1, something like that, and then something like that. Okay, basically it's a summation adding up all these things. So this is not a new thing to you, and this is called the first law. Alright, so don't worry about this one. The new thing, however, is the second law. Okay, you can read all these by yourself. This is more so-called a more complex circuit. Okay, let's take a look here. The word example here, 5.13, is basically what we did in the previous video, so you can ignore this page. And same for 5.14, we did this already, so you can ignore this one. If you like to read the explanation, that's perfectly fine. There's also two examples that we have not covered, which is 5.15 and 5.16. So for these two, I think it's quite self-explanatory, and I would hope you can try to read it by yourself. So if you want to, please pause the video now and read this first, and then we'll continue for the next part. If you have questions, you can feel free to ask me in person. Okay, so let's move on to the actual part that is new to you. Okay, so what we are trying to say is there are situations where we have multi-loop, okay, multi-loop circuit. Let me show you how it looks like first. All right, when we were learning in year 10 or so far, we always only have one battery, one set of battery. So we may have resistor that is like this, and then like that, and then maybe even like this, and then like this, and then maybe there's one like this. No matter how complicated it is, you have seen, it's always one battery, right? So these kind of questions are very simple. All right, it's extreme. You can do the way that you did to tackle this kind of circuit. But then whenever you start to see some new circuit which involves two batteries, so one here you can see and one here you can see, then this question I'm pretty sure that you cannot use the way that you learn to finish it. So that's why there's a new technique and new concepts that will be introduced to you right now. Okay, so basically that is the second law of this guy. How does it pronounce again?
Kirchhoff.
Kirchhoff second law. Okay, and what it says is saying the summation of V, that means the sum of potential difference across the whole loop is 0. Okay, so it may sound very strange to you, like what does that actually means? Take a look of this. I'll do example to you, and you may also want to read this page as well, all right, before we do the example. Okay, because there are actually not many examples that is easy to handle, because that involve quite a lot of algebra. So example with nice number is not easy to suggest. So let's take a look here. If you ever did some like IQ question in primary school, there are some IQ question like this. All right, let me ask you. So let's say I draw a diagram like this. So those IQ questions is usually like asking you, oh, how many triangles are here? All right, so stupid people will say, oh, there are 1, 2, 3, and 4. All right, but then if you are a bit smarter, and hey, that's of course not the case. All right, you also have to count the big one. So this is the last one, right? I think that's all you can make. Or sometimes when you count another diagram like that is like a something like this, and how many square are there, then you may say, oh, there are 9, and of course it's not 9. We also have one more, and one more, 4 more, and also there is the biggest one. So there are actually 9 plus 4 plus 1. All right, so this is something that I somehow can relate to. Here, of course, it's not that difficult. It's not about IQ question. But then if you try to look at this whole circuit, it looks something like this. All right, so what you could do, I mean, you can count how many loop are there will be 1. So that's why this one is 1. And second one, here is the second one. Alright, here's the second one. Alright, and you may also do, sometimes it's useful, sometimes it's not. Sometimes these two will be enough. If not, then you may want to make the third one. Is that this one? Alright, so this is the third one. So there are actually 3 loops in total. So this is something that you need to understand first, like what it means by a loop. Okay, so as you could also see here, and also just now the law is set, right? So the summation of all the V potential difference, that means across everything in the loop, at the end it will equal to 0. So let's take a look here. So if you look at the upper loop, all right, that means this one. Okay, be careful whenever we try to use this approach to solve a problem, you have to define the current first. Okay, doesn't matter which direction you define. So for example, like this question is defining in this direction. Alright, so I call it anti-clockwise direction, but you can actually do the other way around. It doesn't matter. At the end of the day, you may find the current equal to something, let's say 2A, then it's just 2A. If you somehow find the current that you define is negative, then simply just reverse the direction, alright, of your current to be the actual value, to be the actual current. Okay, so it doesn't matter like how you do in the mechanics. Sometimes you find the F actually find out is negative 100 Newton, then that means when you define it, you define in opposite direction. Okay, so don't worry about your direction as long as you define it and be consistent. So let's really start to try to see what it means by summation V equal to 0. First of all, what we have is, look at here. Here we've got a battery, so 6V. So that's why we have plus 6V. So what we are trying to do here is whenever you see the, or we should say it this way, when currents pass through the battery, it gained potential, right? It gained voltage. So that's why it's plus. However, when the current pass through a resistor, it will decrease the voltage. So that's why here we will have minus, okay, for the I1 this one, and also minus the I2 and minus this I1 as well. I think the question already told us here they are all 2 ohm, so that's why times 2 ohm. Let me just label it 2 ohm in this case. And so that's why the voltage, if you recall, V equals IR, then well, that's why this one is a voltage for this one, this one is a voltage for this one, and this one is a voltage for this one. Okay, so you minus this voltage, and this voltage, and at the end it will be 0. And that actually makes sense because this is how the circuit works. Because if you have a battery here, then basically the role of the battery is to maintain a certain voltage. So maintain 6V in this case. So this is positive, this is negative. So if it is positive 6V, then this side must be 0V in this case. Alright, so this is the nature simply. Okay, so once you get this, this is your first equation. And then same for the bottom loop. Okay, bottom loop we have, we also start from the battery here, so positive 6, and then we go along with your arrow direction. So we would have this one, I2, so that's why you see I2. But of course, again, since you go through resistor, you take away the potential difference. Take away the potential, so negative 2I2. And then when you go to this, it will be negative 2I3. Okay, so this is how you construct the second equation. And if you try to look at these two equations, can you see how many unknown are there? Let's try to count. We have I1, I2, and I3. Okay, so 3 different unknown. And as you all know, in no matter how average your maths is, you know that using 2 equations cannot solve 3 unknown. right? So we must have the third equation. The third equation, you may want to use either the whole loop, all right, which is the same way of doing it, but there's actually an easier way, which is simply the first law, if you remember, right? The current is conserved, basically, conservation of the current or conservation of the charge. So if you try to look at the junction J here, then you see that this is I1, this is I2, and this is I3. So what you can see is I1 and I3 would merge at J and go to I2 this direction. So that's why you have this equation as the third equation. Okay, so using three equation, you should surely able to solve three unknown. Okay, so for whatever the rest of the work here, like all the things you could see are simply algebra. All right, algebra. Like if you turn, I think here, yes, at the end. All right, the textbook here will solve you the final answer. Yeah, so on solving it, that will take quite a long of time, but then it would be the way that you know that will solve the problem. Okay, and they also give you a really nice step-by-step guide on how you should do it, and basically that's what I said. Okay, so right now what I would want you to do is on your notes page 12, you should see this diagram. So right now I will try to demonstrate to you how we can do it, and we would do this as an example. You should follow me to do this, and then for the next one I will ask you to pause the video and try yourself, and then we'll check the answer. Okay, so let's try to do this question first. Okay, so let me try this question and you can follow me. All right, if you feel I'm going too fast, you may always pause the video if you want. So here is a diagram of the circuit, and I am being very kind that I already defined you the direction, so you don't have to worry about it. So this is loop 1, this is loop 2, and this is loop 3. Okay, so like how we do, we already defined the direction of current. Then what we have to do is following the I forgot the name again, the actual pronunciation, Kirchhoff law again. So let's start with loop 1, loop number one. Okay, so we will have summation V equals 0. So we have initially coming out here positive 10. I would like to put positive so that to remind myself I know that is really positive. And then you pass through a resistor R1, which is actually 10 ohm. Okay, let's just put down 10. How about that? 10 times I1, again V equals IR. And then at point A you turn going down, and that is 40 ohm. So minus I3, be careful, this is I3, 40 ohm, 40 simply. Okay, and that would get you to return back to battery, so that would be 0 already. Okay, so this is equation 1, and let's do loop 2. Let's just call loop 1 and loop 2. Again, I'll put down summation V equal to 0, and for loop 2 you start with V2, which is 20 volts. Or by the way, our ultimate goal is to find out, of course, I1, I2, and I3. Okay, find all the value of the three currents. Alright, just so you know, that's what we are trying to do. So let's start with 20, this battery, 20 here, and then we have 20 ohm, so minus 20 times I2, and then we go down again, just like the one we have for equation 1, and then it go back. Okay, very simple. Okay, so I will try to use the first law again, which is like looking at junction A. So maybe you may want to put that at A, that you can see 1 is going this way, 2 is going this way, and then they merge as 3. So I1 plus I2 equals to I3. Okay, so we have equation 1, equation 2, and equation 3. And the rest of the work is simply solving the equations. Okay, so I think I will skip this part. I'll show you once I finish it. Okay, so here is the workout for the algebra process itself. So what we have is I think the easiest way to do is, since you can see this is a negative I340 and in equation 2 is also the same, so it would be better if you could not take that away. Like if you try to add, like minus them, and you get the I3 away, that I don't think that would be a good way to solve the equation. I think the easiest way to do is I would times 2 for I1 for equation 1, and then plus 20. The best thing is you could see I can get this and these to be like these to be I3. Okay, like this one. All right, and then eventually you will only have I3 in your equation. Alright, this become I3, and then this I3 and this I3, and then the rest will be constant number. And then eventually you can solve I3. And after you solve I3, simply you just substitute that back to equation 1, equation 2, and you should be able to get I1 and I2 separately. Okay, so the answer for I3 is this one. I1 will be negative, and I2 will be a positive number. So as I said, if you find something that is negative, don't worry too much. What that means is, for this current 0.149A is actually going in the opposite direction. Okay, so actually going in this direction instead. Okay, and for the other two, just remain as it is. Okay, so for now, I would want you to try the next question. Pause the video now and check the answers afterwards. Okay, so let's try to do it for now. So as what you should do for the first step, you need to define the direction of the loop. So I think it's more intuitive to define this as I1 going this direction and I2 in this direction. So you can see that they would merge like here, I3. Okay, so like how we do, let's construct the three equations. So for loop 1, we would have again summation V, I'll still write it down, and then we have positive 32, this one, the battery, and then minus I1 times 2, sorry that the symbol is missing, should be 2 ohm here, 4 ohm here, and then 20 V and 32 V and 8 ohm like this. Okay, so through the middle, and it will be minus I3 times 8. That's equation number 1. For loop 2, okay, I'll write directly this time. It will be positive 20 minus I2 times 4, this one, and same I3 times 8. Okay, equal to 0. And that's equation 2. And then for equation 3, as usual, is I1 plus I2 equals to I3 by looking at junction B here. Okay, that's equation 3. Okay, so by solving these three equations, then you should be able to find the answer. So I would do it first, and then I'll come back to you. Okay, done. So the approach that I try to solve this algebra equation, again, there are so many different ways, but the way that I did is similar to the example just now. So I will also try to times 2 for equation 1 and plus the equation 2, because once again, I will want to make these and these to kind of match the coefficients, so that when they add up together, when they put together, then that will become I3. Okay, so I think you should be able to read all these things, and then you should find I3 will be 3A. And then for substituting this into equation 1 and 2, then you will also find I1 to be 4, I2 to be negative 1A. So as we say earlier, if you find a negative number, then you would it will mean that the current I2 is actually flowing in this direction instead with 1A. Okay, so this way and this way, 1A. Okay, and that in fact yeah, it's very normal to have a voltage like this, to have a current like this.